video we focus on linear equations in two variables. A linear equation is an equation of the form y equals to ax plus b, where we notice that the right hand side induces a polynomial of degree 1 because x is raised to the highest power of 1. The language of linear simply comes from the fact that these equations have a line as a graph, but in more advanced mathematics we're going to notice that this language of linear is actually used in a different context. First, let's start by graphing a linear equation. And we're going to try and find the easiest technique in order to graph these equations. And that's going to rely on plotting points. And let's understand how many points do we need in order to graph a linear equation. Well, let's start with 1 point. If I had 1 point that happens to be on this line, does this uniquely determine my graph? And the answer to the question is no, because through one single point I can draw not just 1 or 2 or 3, but in fact infinitely many lines. So 1 point is not enough. So what about 2 points? If I knew these 2 points happen to be on the graph of my line, is that enough to uniquely determine my graph? And the answer to this question is yes, because given any 2 points, I can only draw a single unique line through these 2 points. So 2 points are sufficient for me to be able to draw the graph of my line. Therefore, the technique we're going to use to graph a linear equation is simply going to be find 2 points on my line, and we're going to draw the line through these points. I want you to understand that picking a third point in order to plot is really not needed. If you're going to do it, is simply to check your work, because the first 2 points really uniquely determine the graph of your given line. So let's actually look at an example. So let's start by, say, graphing the line of equation y equals to 3x minus 1. So as I said before, we need to pick 2 points that happen to be on this line. So how are we going to do that? Well, let's just pick an arbitrary x coordinate, let's say the nicest number, x equals to 0, and compute the corresponding y coordinate. So let's see, if x is 0, I get 3 times 0 minus 1, and therefore y is negative 1. So we know that the point of coordinates x is 0, y is negative 1, happens to be on the graph of my line. And now let's just pick another point. Let's say if x equals to another nice number 1, then y happens to be 3 times 1 minus 1, and that's 3 minus 1, which happens to be 2. So we have the point of coordinates x is 1 and y is 2. So now, once I have these 2 points, I can plot my line. So let's draw a Cartesian plane and plot the points. If x is 0, y is negative 1. So my first point is right here on the y-axis, and my second point, if x is 1, y is 1, 2. So we have this to be our second point. And now all I have to do is draw a straight line through those 2 points, and that happens to be the graph of my line. Let's do one more example. Let's say we want to graph the line y equals to negative 2x plus 1. So again, we pick 2 points. So let's say if x is 0, then y happens to be negative 2 times 0 plus 1, so 1. So we get the point of coordinates x is 0, y is 1. And also, if x is 1, then y will be negative 2 plus 1, so negative 1. So I get the point of coordinates x is 1 and y is -1. So now let me draw this line. Let's first plot the points. If x is 0, y happens to be 1. So if x is 0, y is 1. That is my first point. And my second point, if x is 1, then y happens to be -1. So this happens to be my second point. And now I just draw a straight line going through these two points. The next concept that we want to introduce is that of the slope of a line. And we denote the slope by the letter m and use it as a measure of inclination for my line. We define it as follows. Given any 2 points, for example these 2 points on the line of coordinates x1, y1, x2, y2, we define the slope as the difference in the y coordinates, so y2 minus y1, and divided by the difference in the x coordinate, x2 minus x1, namely the rise, namely the change in y, over the run, the change in x. And this formula only works if x2 is not equal to x1. So a nice observation to make is as follows. If the slope is positive, like it was in this particular case, then we're going to have an increasing line. So we want to notice that in this case the slope was positive and therefore my line was increasing. In this case, however, my slope in the second case is negative, and as it was here, and so the slope of my line being negative makes the line being decreasing. So let's use this formula now to try to compute various slopes of lines. So let's say we want to find the slope of the line through the points 1, 2 and the point 3 and 5. So we write down that m is the difference in the y coordinates over the difference in the x coordinates. It's always nice to tell the reader what particular formula you are using, so get in the habit of always writing out the formula, not just going straight after the numbers. And now we need to decide how to plug these numbers into this formula. Well, there was talk about a first point and a second point, so let's just say that this happens to be my second point. It really doesn't matter, you could have chosen it differently, and let's say this is my first point. Having made those choices, now I'm going to take the y coordinate of a second point, namely 5, that happens to be y2, minus the y coordinate of the first point, that happens to be 2. And now the x2, which is my 3, the x-coordinate of the second point, minus 1, which is the x-coordinate of the first point. So the difference gives me 3 over 2. So this number represents the slope of my line. And again, we notice, based on our previous observation, that this happens to be an increasing line because it has positive slope. Let's now look at the slope of two special lines. So let's say that we're trying to find the slope of line through the points 1, 3 and let's say 2, 3. So if we try to use the same formula, namely m is y2 minus y1 over x2 minus x1, we're going to have 3 minus 3 divided by 2 minus 1. So we get 0 divided by 1, which equals to 0. So we've obtained a zero slope, and this is quite a special number, so let's try to understand what's going on here. What was the source of the 0 over 0? It was the fact that the y coordinates in both points happen to be the same. And these lines where the y coordinates happen to be the same are special lines, and we have a name for them. So say, let's plot them to understand. If x is 1, y is 1, 2, 3. So that's this first point. And if x is 2, then again I obtain the same height, namely of 3. And we notice that when I draw this particular line, it is a horizontal line through the height at 3. So we notice that all such lines, because again the y coordinates will maintain the same height, will all share the same property, namely that they have the slope of 0. More so, in order to record the equation of such a horizontal line, what we're going to do is simply record the coordinate that is fixed. So as I move across this horizontal line, what coordinate changes? The x coordinate changes, and what coordinate stays fixed? The y coordinate, namely the height, stays fixed at the value y equals to 3, and this is the equation of my horizontal line. Very similarly, let's look at vertical lines now. So let's try to compute the slope of a line through the point of coordinates, say 2, 1, and say 2, 3. So if I try to use the same formula, y2 minus y1 over x2 minus x1, what I notice is that I have 3 minus 1 over 2 minus 2, which is 2 divided by 0. And this happens to be an undefined operation, because division by 0 is an undefined operation over the reals. So, as before, if I try to plot these 2 points, so let's just draw a graph. If x is 1, 2, I get the height of 1. And if x is again 2, I get the height of 3. So we notice that we're getting a vertical line in this particular case. And all vertical lines are going to have the slope undefined, because we're always going to get 0 in the denominator. So the slope is undefined. And as before, the way we try to remember on how to write down the equation of a vertical line is, or a horizontal line is, we think as we move up and down on this particular line, which coordinate stays fixed, and that happens to be x at the value of 2, and that is the way I record the equation of a vertical line. Vertical and horizontal line are going to play an important role when we're going to talk about asymptotes. So it's really important that we remember how to record their equations. Namely, just think as I move up and down this line, which coordinate stays fixed, and that's what I'm going to record. In general, if I have say a point of coordinates say A and B, if I have a vertical line going through that point, then the equation is going to be what? Well, the x coordinate is fixed, namely at the value of A, so we record again the coordinate that is fixed, and this represents the equation of my vertical line. On the other hand, if I pick the horizontal line going through this point, well, the height stays fixed as I move through this line. Namely, the height is the y coordinate, and that stays fixed at the value of y equals to b. and this is how I record the equations for a vertical and horizontal line for a general point. In calculus, we're going to focus on lines in a specific context, namely the differential part of calculus is going to teach us how to locally approximate functions, nice functions, by lines. So for that reason, we're going to use a specific form of the equation of a line, namely it's not the usual slope y-intercept form, but we're going to focus on a slightly different form, more general form, namely the point slope form of the equation of a line. This form, as I said, is the most useful one in calculus, namely we want not just the y-intercept but an arbitrary point in order to write a equation, this particular form of the equation of a line. So here is the equation of the form of the equation of this line. So it's going to be y minus y0 is m x minus x0. Now x and y are my variables as usual, and then I'm going to have m represent the slope of this line, for example 2/3, -1, whatever it is, and then x0 and y0 are the coordinates, x and y coordinates of a point on my line. So given a point on the line and the slope, I'm able to write the equation of a line in this particular form. So let's look at an example. So find the equation of the line of slope, let's say 3, and going through the point of coordinates 1 and 5. So we write the general form of the equation of the line. As I said before, we always want to tell the reader what formula we're using. So y minus y0 is m x minus x0, and now we have to determine 3 items. First, what is the slope? And in this case, I'll give it to you, namely it's 3. Then what is x0 and what is y0? And we notice that we have a point that happens to be on this line, namely the point of coordinate 1 and 5. So the x coordinate of 1 gives me x0, and the y coordinate of 5 gives me y0. Now I can write the equation of this line, namely I obtain y minus 5 is m, which is 3, x minus 1, and this is the point slope form of the equation of a line. A slightly more difficult exercise. Let's find the equation of the line through the points 1, 5 and 2, 3. So again, we have the same equation, y minus y0 is m, x minus x0, and now we're trying to find x0, y0, and m. We're always trying to find these 3 parameters. So x0 can be determined by finding a point on the line where either of these 2 points is on this line. So let's just pick the second point. So then x0 is 2 and y0 is 3. For m, I didn't give it to you here, so we're just going to use the formula for the slope, y2 minus y1 over x2 minus x1. So we're going to have 3 minus 5 over 2 minus 1. And that gives me -2 over 1, so the slope is -2. So put together, we obtain y minus 3 is -2 x minus 2, and this is the equation of the line in point slope form. as a last example to practice this form of the equation of a line, let's recall that two lines are parallel if they share the same slope, namely the same level of inclination. So m1, the slope of the first line, equals to m2, the slope of the second line. And two lines are perpendicular if m1 is the negative reciprocal of the second line. So let's look at an example now. Let's say that we want to find the equation of the line that is, say, parallel to the equation y is 2x minus 1 and goes through the point of coordinates 1 and 5. So as before, we have the point slope form equation of the line, and we're trying to find x0, which in this case is 1, y0, which is in this case is 5, and then the slope, which we're going to retrieve from the fact that we know our line that we're after is parallel to the line of equation y is 2x minus 1. So since parallel lines share the same slope and the slope of this line is 2, we're going to have that m is 2 in this case, and we obtain the equation then y minus 5 is 2x minus 1. So as a final example, let's say that I want the same exercise, only that now I want the line that is perpendicular to the line y is 2x minus 1 and goes through the point of coordinates say 1 and 6. So similarly as we had before, we're trying to find the x0, which is going to be 1, the y0, which is going to be 6. We're looking at the coordinates of a point on the line, and that happens to be this 1 and 6, and we're going to try to find the slope. Now, knowing that the lines are perpendicular tells me that if I find the slope of this first line, namely 2, in order to find the slope of my line that's perpendicular, I will have to take the reciprocal and then put a minus in front of it. So we obtain the equation y minus 6 is negative 1/2 x minus 1. The concept of lines, while it's not very complicated, it's very important that we really get a good grasp of it, because as I said in calculus, the geometric interpretation of the derivative will be the slope of a line, so we will be focusing a lot on lines. So it's really important we understand and remember the formula for the slope, the point slope form of the equation of a line, as well as the equation and the slopes of vertical and horizontal lines.